In the ever-evolving realm of contemporary technology, the centrality of blockchain technology cannot be overstated. As its prominence continues to burgeon, the discerning developer must inquire into the pivotal technical skills and programming languages that underpin blockchain development. Fortunately, the landscape of blockchain development accommodates a myriad of familiar coding languages, including but not limited to C++, JavaScript, Solidity, Rust, and AssemblyScript. Notably, newer languages tailored for smart contracts, the fundamental constructs of programmable blockchains, are amenable to those possessing rudimentary coding proficiency. However, prior to embarking on the selection of a specific language, it is judicious to meticulously research and discern the language that aligns most aptly with one's envisaged application. Within the sphere of smart contract development, the bedrock of programmable blockchains, two formidable contenders emerge: Solidity and Rust. The selection between these two languages hinges on the projected services of the platform under development. Solidity, origins and attributes. Solidity, an object-oriented high-level language, exhibits a predilection for data and objects over intricate functions. Distinguished by its static typing, Solidity boasts the ability to detect errors during compilation, thereby endowing it with a heightened level of reliability. Its genesis was as the designated programming language for smart contracts within the Ethereum blockchain. Noteworthy is Solidity's adaptability, extending its dominion beyond the Ethereum realm to encompass networks such as Polygon, Avalanche, Polkadot, Optimism, and Arbitrum. Its design enables portability across devices equipped with an Ethereum Virtual Machine (EVM) executor, ensuring seamless execution across divergent platforms. Several factors endow Solidity with its eminent status as a preferred choice for smart contract development, especially in the context of Ethereum compatibility. Built-in conditionals. Solidity streamlines the process of executing actions contingent upon specific conditions, obviating the need for intricately scripted conditional statements. Developers can encapsulate conditions directly within the source code, thereby expediting the development lifecycle. Data typing proficiency. Solidity presents an assortment of built-in data types, encompassing integers, strings, floating point numbers, and arrays. Moreover, developers retain the prerogative to fabricate custom data types bespoke to their smart contract exigencies. Safety in development. The Solidity compiler diligently scrutinizes developers' code for potential errors during the coding phase, providing salient feedback regarding prospective pitfalls. This feature assumes paramount significance when tackling extensive and intricate decentralized applications, DApps. Nonetheless, Solidity carries certain limitations. As a high-level language, it might not be commensurate with the rapidity characteristic of lower-level languages. This velocity deficit may prove detrimental when handling intricate smart contracts or a profusion of transactions, a vulnerability exemplified by the infamous DAO hack, which underscored Solidity's susceptibility to design flaws culminating in security breaches and financial losses. Rust, a distinct paradigm. Since its inauguration in 2015, Rust has garnered substantial acclaim and commendation among the developer echelons. It has perpetually occupied a place of esteem as one of the most cherished or revered programming languages on platforms such as Stack Overflow, spanning an uninterrupted 8-year tenure. What renders Rust a cherished favorite among developers? Rust artfully navigates the intricacies of furnishing a high-performance tool for application design while concurrently upholding the tenets of security, thereby serving as a bulwark against potential vulnerabilities. Rust's distinguishing features encompass a robust type system and uncompromising memory safety, assuring performance excellence. Rust enjoys repute for its celerity and memory frugality. Devoid of a garbage collector, Rust lends itself amicably to underpinning performance-critical services, deployment on embedded devices, and seamless integration with sundry other programming languages. Reliability fortified. The opulence of Rust's type system and ownership model guarantees memory safety and thread safety, empowering developers to interdict many categories of bugs at the compilation stage, thereby galvanizing the overall reliability of the codebase. Productivity augmented. Rust bequeaths developers with a cornucopia of resources to amplify productivity. These include comprehensive documentation, an affable compiler replete with illuminating error messages, and superlative tooling. Integrated package management and build utilities, coupled with intelligent multi-editor support replete with auto-completion and type inference, culminate in a seamless and efficient development experience. In the context of blockchain development, developers harbor certain yearnings, a trifecta comprising safety, velocity, and facile multi-platform development. Rust emerges as the harbinger of these desiderata by virtue of its resolute attributes. Security bastioned. Rust's stringent memory safety fortifies defenses against common vulnerabilities such as buffer overflows and data races, rendering it an ideal choice for crafting secure blockchain applications. Performance pinnacle. Rust's adroit memory management and absence of a garbage collector facilitates seamless operation and optimal performance of blockchain applications, even in resource-constrained milieus. Cross-platform harmonization. Rust's innate compatibility across diverse platforms positions it favorably for the development of blockchain solutions primed for seamless functionality across an array of devices and operating systems. In summation, the dichotomy between Solidity and Rust for blockchain development pivots on project-specific requisites and objectives. While Solidity proffers simplicity and harmonious compatibility with Ethereum and Cognate EVM-based networks, Rust stands distinguished by its unparalleled amalgamation of security, performance, and developer-centric attributes. Evidenced by Vara Network's discerning embrace of Rust, the language has demonstrated its pragmatic value for avant-garde blockchain projects, keen on harnessing the entire spectrum of decentralized technology's potential. Whether the compass veers towards Solidity or Rust, an intimate familiarity with the chosen language and its ecosystem is incumbent to unlock the full panoply of blockchain development's potential in the contemporary technical milieu.